All right, guys, welcome to the problem set video. Let's go ahead and zoom in so we can actually work on, oh, not fit to height, fit to width is the better one. Let's get our names on these. One of the things that we weren't doing during the lesson on the concept was this first part that it's asking us to do is estimate the product, and that's something we did yesterday's lesson, so this shouldn't be too hard of a stretch here. So 22 is approximately 20, right? And 2.4 is approximately 2, so our answer should be close to 40. Okay, so let's go ahead. That was the estimation part. Um, and then we're going to solve using the area model and standard algorithm. I know some of you are going to be like, do I have to do both? Yes, please. On this section, yes, please. So let's go ahead and represent 24 on the top part of our, remember this is tenths, so we're going to write that down, 24 tenths, and then we're going to have 2 and 20 for the 22 on the side. Well, let's go ahead and solve inside of these. The next one I'm going to make you do a little slower. So I'm going to pause and not make and do it for us. So I know that these are tenths. So let's go ahead and add 480 plus 48. Remember, if I'm going too fast, please pause me. This is 528 tenths. Or 52 and 8 tenths. So let's go ahead and show that over on our problem set. Well, remember, we've been practicing this a lot. We're going to do 2 times the top number. Well, 2 times 4 is 8. 2 times 2 is 4. Well, there's my 48 tenths. That's the same as my partial product in my area model, even though my yellow 8 is a little sloppy. I apologize for that. The next part is when we do 2 tens times the top number. So now that we've moved into the tens place, we can go ahead and represent that with a 0. 2 times 4 is 8. 2 times 2 is 4. 480, that's the same partial product in my area model. 8, 12, 5. So that's 528 tenths. And we can convert that back to standard form as 52 and 8 tenths. Okay, now I would like you to try to do those exact same steps down here. Let me help you estimate though. Well, it's close to, oh, I forgot their approximate sign here. Do you notice that? I hope somebody noticed that. Let's get the approximate sign in here. Well, it's approximately 3 times 30. So our answer should be close to 90. Okay, let me help you set up the area model. We're going to do 3 and 30 over here for 33. And then we got to convert the 3.1 as 31 tenths, right? So it's going to be 30 plus 1, and then we're talking about tenths. Okay, I'd like you to solve for the area model and then try your best on the standard algorithm. And then, so you're going to pause me, you're going to try the best on your area model, see how you do it on the standard algorithm, and then resume me to check your work. All right, let's check your work. Hopefully you were checking it just as you're doing the area model and standard algorithm. I'll show you what I mean with my work. Remember, every time I do my partial products in both methods, I check these partial products, and you can tell that I did that with my little check marks. So I knew that I was either making the same mistake in both places, which is kind of unlikely, um, or something else was weird. But if there was a mistake or if there was a difference here, then I could have started analyzing it. But also make sure that you show me that you know how to then recompose it back into standard form. All right, let's go ahead and see what the next part of the problem set's asking us to do. It says estimate and then just use the standard algorithm to solve. Express your products in standard form. Let's do A together, and then you're going to do B on your own. And then you'll check your work. So this is close to 3 times 50, right? Close to 3. So this should be close to 150. Well, they've already decomposed the tenths for us into 32 tenths. So now we just have to, and they've already set it up in standard algorithm. Oh, that's a too fat of a highlighter. Let me get a smaller one. We're going to do the ones times the top. So it's 14, 7 times 3 is 21, plus 1 more is 22, right? And then I'm going to change colors to make it easy for you guys to see. Now I'm working on 4 tens, so I'm going to represent that 4 tens with a 0. 4 times 2 is 8. 4 times 3 is 12. Let's go ahead and add those. 1,504. Remember, we got to bring down that unit. So it's 1,504 tenths, or 150.4, which is really close to our estimate. Nice job. Okay, so let's estimate together. Then I'm going to ask you to work on this math problem yourself. And it's close to 3 times 90. So that should be close to 270. Now we rounded down by both, so this answer should be, our estimate should be a little smaller than the actual answer. So you're going to pause me and you're going to go ahead and solve 32 tenths times 94. And you're going to then remember to recompose it back into standard form. All right, so pause me, and when you come back, when you're ready, I'll have the answers. All right, let's check your work. Check your partial products. If you are making a mistake in one of those, that means you've made a multiplication mistake. If those are accurate, and you have the mistake down here, then you've made an addition mistake. So this is just how you can analyze your work. It's exactly how, when I look at your work, that's what I'm looking for. I'm looking for, is it a multiplication mistake? Is it an addition mistake? Or is it a conversion mistake? Okay, so check those places and understand what you're looking for. All right, let's go ahead and flip the page. Okay, it looks like we have a couple more to do. This time they're not setting it up for you. So let's go ahead and if you feel like you can convert these real quick, go ahead and pause me and convert them, and then check your work with me. Well, I'm going to just rewrite the expressions real quick. This would be 63 tenths times 44. Right below it would be 82 tenths times 34. Up here would be 146 tenths times 17. Oops, that's a bad 17. And then down here would be 1,604 tenths times 17. So remember, if we're going to set these up, it would be 63 times 44. But remember, these are tenths. This would be 146 times 17. This would be 80. That's a bad 8, but 82 tenths times 34. This would be 1,604 tenths times 17. Now, I would like you to choose 2 of these 4. Yeah, there's a word problem right. Choose 2 of these 4 to go ahead and try to solve using standard algorithm, and also try the estimate. When you come back, I'll have the answers to all 4 of them, and you can check the 2. And remember, we're going to check to see if we had a multiplication mistake, whether it's an addition mistake, or whether it's a conversion mistake. Okay, so I'm going to pause. You're going to pause. You're going to do 2 of these 4, and we're going to come back to check our work. Now, if you're struggling with standard algorithm and you want to draw an area model off to the side to help you, please do that. I want you to feel successful. All right, let's go ahead and pause, and we'll get working. All right, let's check your work. I know I ran out of space, so I hope that you guys got to be able to fit it in. I know sometimes using the stylus is not the easiest to get it nice and small, but yet still legible for you guys to read. So let's check our partial products. Remember, that's a multiplication mistake. If you made mistakes there, check your answer for an addition mistake, and then check the standard form for a conversion mistake. It's really helpful to know and analyze your own skills and be reflective on that. So again, check your partial products. Ooh, that was a bad highlight. Can't use yellow over yellow. I ran out of room, so I moved the partial products to the right. Here's my addition, and then let me move my thing. There's the standard form conversion. Okay, let's go ahead and move down. Here's our partial products for this one. Here's our addition, and then here's our standard form conversion. Again, here's our partial products over here on the right. Here's our addition. Here's our conversion. So go ahead and check those. Correct any mistakes. Notice what mistakes you're making so that you can try to avoid those on future problems. And let's go ahead and look at this word problem. So we got 2 word problems. So let's go ahead and just work on the hardest word problem together, and that's number 4. So last problem together before we go to the exit ticket. Let's go ahead and read it. It says a wire is bent to form a square with a perimeter of 16.4 centimeters or 16 4/10 of a centimeter. How much wire would be needed to form 25 such squares? Well, we know the perimeter of 1, and we need that for 25 other squares. So we're making 25 copies. So it's the expression will be 16.4 centimeters times 25. Or if we converted this to our unit form, it's 164 tenths times 25, which we can do simply, just make sure that we write that that's tenths. I almost forgot to write it. We know how to do 164 times 25, but it wants us to convert it back to standard form and especially meters. So we're going to have to go from centimeters to meters. So we'll talk about that in a second. But really, I want to see the multiplication of 164 times 25 accurate, and then we'll work on those pieces. Well, 5 times 4 is 20. Right? 5 times 6, 30, plus 2 more is 32. 5 times 1 is 5, plus 3 more is 8. Again, I can't stress enough how much it's important to practice your multiplication facts, because nothing is more frustrating than you having to think about what is times what equals what while you're trying to learn all the steps of 2-digit or multi-digit multiplication. Now that we've shifted over to, we're done with our ones place, right? We've multiplied 5 by the entire top. We're now onto 2 tens. So we show that by the 0 down here. 2 times 4 equals 8. 2 times 6 is 12. 2 times 1 is 1, plus 1 more is 3. So we can then go, whoops, that's the wrong place. We can then go ahead and add these, and we should get 4,100. But that's 4,100 tenths. So let's go ahead and convert that back. So that should be 410. Now it was 410. Remember, this is a pretty tough problem because it's asking us to go back and forth. Well, it was 410. What was our original unit? It was centimeters. So it's 410 centimeters. But now it wants us to convert it back to meters. Well, if you can get to the answer of 410 centimeters, I'm super, super happy. If you can get this, I'm ecstatic because this is a little bit hard. Think about how many centimeters are in a meter. One of the tricks I use for this, how many cents are in a dollar? Well, cents in a dollar is 100, so centimeter is 100 centimeters in a meter. It's just one little trick that I worked. If it works for you, great. But 100 centimeters in every meter. So, well, there's 4 hundreds in this, so that means there's 4 meters, and the rest is going to be centimeters. So it's 4 meters and 10 centimeters. But we need to finish with a word problem. I'm going to write it above it. Whoa, got to do a lot smaller text than that. Let's go to, come on. Oh, I got to move my book. I put a book on top of my keyboard so I would stop typing on it. Let me change this to 16. Let me move it up. So how much wire would be needed to form 25 such squares? Well, we can just start saying caps locks. You will need 4 meters and 10 centimeters of wire to make 25 squares. Perfect. All right. That is our problem set. You now can go on to exit ticket. Please, please. There's some of you that are struggling with taking clear pictures on your exit ticket. I need to be able to analyze your skills to help you become the best mathematician that you can be. So please, if you can't read it after you take a picture, do not submit it. Only submit pictures that you can actually read your own work on. All right, guys, thank you. And I'll see your exit tickets.